Heinemann Higher. Chapter 6 in Differentiation, the mixed exercise 6S at the end, number 12. And all it tells you here is that you've got this diagram, this graph of this cubic function. The line AB is a tangent to A, and you have to find where it cuts the curve again at B. Well, that must mean you're trying to find a point of intersection, so you'll need to know both equations to equate them at that point. So the first step is going to be get the equation of that red line, get the equation of the tangent at the point A. Well, I've got the coordinate equation, but I don't really need that straight away because I already know the y coordinate, so I'll differentiate that to get the gradient equation at each point on it. So that constant will just disappear, and I've got negative 3x squared, which means that at x equals 1, the gradient, which is given by dy by dx, that's a bit messy, will be negative 3 times 1 squared, which is negative 3. Which doesn't look much like that because that graph isn't obviously to scale. So the gradient is negative 3 and the point is 1, 7. So I've got, should put that again there. Gradient of negative 3. Gradient of negative 3, 0.17, so now I can get the equation of the line AB. So that'll be y minus b is mx minus a. Y minus the y coordinate 7 is the gradient, negative 3 times x minus the x coordinate 1. Get that into the form of y equals mx plus c, a very good form, especially for substitution to find intersections. So that'll be negative 3x, that's going to be plus 3 plus the 7 is plus 10. So there was my original equation, and here is the equation of the tangent. Then, to find the point of intersection, I'm going to substitute them. So to find the point B, I'm going to substitute this equation into number 1. Substitute 2 in 1. Which means instead of that y, I'm going to write this. So I'm going to write negative 3x plus 10 equals 8 minus x cubed. And taking that to one side, I've got x cubed minus the 3x plus 2 equals 0 to solve. Now, straight away, this expression requires factorising. Now, there are techniques for factorising polynomials where the degree, where the power is higher than 2, but that's not till the next section, strictly speaking. So if this is occurring in this section, you'll have to pretend you don't know about the synthetic division and so on. But what you do know is this. If it's power 3, there should be 3 factors, because an x times an x times an x would give x cubed. And if a line is a tangent, then that accounts for 2 factors, because normally if I had this line cutting a curve, it could cut it up to 3 points. I should have 3 distinct factors. I would have 3 factors, there'll be 3 factors for this factorisation, where they'd all be different. However, if that line moves up, so it then just joined, these 2 points joined together there, then a tangent point for an intersection is a double root. There should be a repeated factor there. So I know that one of the answers is x should be 1, so one of the factors should be x minus 1. And since it happens twice, because it's a tangent point, that means 2 of the factors are x minus 1. And all I've got to figure out now is, with a process more or less the same as you do for quadratics, because I've got 2 parts, what would fit in here to fit with these? Well, the first terms must give the first, so an x times an x must just be an x to give the x cubed. And the last times the last times the last must give a 2. So I've got a positive 1 would have to multiply a positive 2. So from this I get my answers. I get x equals 1 twice, which implies a tangent point, and a single point, x equals negative 2, which would be at the point B. So I can say straight away, and I've run out of room, that at point B, x equals 2. So at B, x equals negative 2, since A already claimed the 1. And then to find the y coordinate, simply put that back in. I've not left myself enough room, so I'll go back up here. So if I've got x equals negative 2, that means y will be 8 minus the negative 2 cubed. 8 plus 8, so that's going to be 16, which means that B is going to be the point negative 2, 16. And there it is. Right, that was question 12.